What is up, everybody? My name is Richard Terrell. I go by Kirby Kid, and you are watching me run through a feature for a game that I made. This feature I coded in about 2018, 2019, so it's been a few years. And this game I started in 2016. So it's called enLIGHTen, Learn the Art of Learning, which you can see here. But it's a game that teaches you how to learn. You play the puzzle game. It has all kinds of interesting tools, features, feedback, and there's a website for it, which I'll link in the description. But ultimately, this is a single feature that I worked on. It's the last and most complicated feature, and I wanted to make sure I got some footage of it. So before we take a look at it, oh yes, I'll just show you some of the scripting behind it. So one of the interesting things about learning is that it's built up of smaller experiences and smaller models and smaller pieces, and it's how you acquire those experiences and then how you process it. It's really makes up the entirety of human intelligence, right? So this game was trying to help people develop some of those foundational, fundamental skills, and one way that I thought of to bring that whole picture home, to really sink that lesson in deep, is to allow people to convert their thoughts into computer code. Now, there's no simple way to do this, but the method I chose was to create a visual scripting system in the game that you could almost use your everyday normal speech, and then you could create these algorithms that the system could run for you. And once it's in the system, it can run it at 100x speed. It can do all kinds of things for you. So I really thought once players get to the point where they are thinking about these rules, that's really the highest level they can be, because once you understand this is all there is to it, the world is open to you. So essentially I made this system. It's called the method maker. You're making your methods. I can show you the menu here. enLIGHTen, the learning model, basically you take your inspirations and your free thoughts and you explore things, and that's the first layer, something to satisfy your curiosity. The second layer is some structure in order to help you measure your skills or test certain things. The next layer is taking the thoughts that you have from those tests. So taking all your thoughts and organizing them in a list and reviewing your notes and stuff, and trying to make sure that what you think is coherent. Then the final step is to organize those thoughts into different ways, like building hashtags in order to group them into conceptual groups, or sorting out one style of puzzle versus another, or one thing from the other, and really finding the differences. So that whole process, that's what I call a process. You develop methods and algorithms and strong strategies from doing all those things over and over. So I wanted to give the player the ability to, string together commands in order to do that. And I created roughly 53 different scripts, 53 different versions of these little nuggets that you can stack together in different ways in order to accomplish what you're trying to do. But here's the definitions of them in a little bit more readable sense. But yeah, I made it to where you can specify a target of a cell, or find the densest areas of lights, scan for a known pattern, count the number of lights, apply clicks, adjust the target that you might apply to where you want to click, push a light pattern into the board itself, or remove lights from the board in a certain pattern, or punch in the lights in a certain pattern. And then I give you 5 different tools to sort of to help you understand what's going on behind the scenes, like a bag that keeps track of every click that you make, kind of like bag random in Tetris or whatever. You have to pull out every piece once before you can pull out a duplicate. I created that. Scan for hidden patterns using the hidden shapes scripting. And then something to manipulate the game itself. So rewinding the turns, setting an anchor a certain number of turns back so you can return to a specific turn and explore. Targeting what cells the hottest in terms of the density of lights. This method switch is interesting because you can create a whole script And at some point you can say, if this condition is true, switch to an entirely different script and run that. So it basically allows you to create whole methodologies and then switch between them intelligently based on conditions. And then, breakpoints and different ways to modify the bag and the other limiters that I have behind the scenes. Different ways that you can score the field to evaluate, like, let's say you really like clicking on the diagonal, like, top leftmost light. Well, in order to figure out what the top left one is, you have to score the lights vertically and horizontally so that the system can tell, this is the light that has the highest score. It must be the most top leftist one. So I give you various tools to score and to check what cell state is, lit or unlit. Counting the turns. Then I added some clever ones like feedback, where if this node triggers, you can select a sound effect from the game and have that play. The if output is your major if evaluation node. And then all of these other kind of ideas that I never got to past 50, I never got to them, but most of them were created, so that's kind of the good thing. Here they are all right here, and every script runs through two steps, one to calculate what it needs to do, and the second one to enact whatever step that is. And the reason for that will become apparent in just a second. Let's take a look. Am I recording? Yeah. So this is the game, especially if you haven't seen it before. This is what it looks like. And you just click stuff in the grid, and your cross-shaped cursor swaps lights back and forth. So when we're making a method, the first thing we can test is let's just build a new one. Method shaker, delete, and let's start a new one. So you start a new one, you got to give it a name. We're going to call this one random click, and this clicks things randomly. You can save it. The first node you add needs to specify a goal, because every method has a goal in mind, like a series of steps, but oftentimes when you're playing a game there's a goal. So I wanted people to solve. Is puzzle solved? And this list automatically grays out all the nodes that aren't goals and leaves you with the only ones you can click. So solved. Boom. Save it. And now we can add a node. Target cell at random is the first one, so it's the easiest one to understand. And then we're going to say add a node, apply, click. So it's going to find a target and then click it. And that's really all there is to it. You save it, you exit, and then you go run it. And if we run this hopefully one time, it did it twice, that's fine. But you can see it targeting a cell like this. Like, I can click these things in real time to show you that every step is very simple, every step is very coherent, and you can even mix and match your own methods on the fly. You can rearrange your steps just by clicking on them live. So I can just do this and manually go like, what does it look like to constantly target a random cell? And then what if it looks like if I applied the click there? And you can walk yourself through your own methods. It's really cool. So that's the first thing. It's the most straightforward example. I can do this, reset, and then we can go back into it and go like, okay, we just don't want, well, let me show you the results of that. So if you have a random click like this, run it, random click, and we put the cycles up to 25, let's say 25, and we drop the speed. The speed doesn't work, I wish it did, but it's supposed to make this a lot faster. But for demonstration purposes, you can see it happening. A bunch of random clicks. Cool. So it's a bunch of random clicks, and this is what we get. It doesn't look too pretty, but what's cool about this system is it always overlaps with all your other tools. So what just happened actually registered in the game. I can rewind it and re-examine it like this, or I can check the click keeper and look at that. I did 25 clicks, but obviously there's less than 25 clicks here in the click keeper, which means some of them were redundant. And this is where we start to explore some of the more powerful aspects of the tool. You go to the method shaker, we edit it, random clicks, and there's inside of each of these nodes can be parameters. Target cell at random, identify a single cell based on pure randomness or picks a cell out of the bag. We want to do bag random, so I slide that over, it knows what that means, and then I click X. And now when we save and apply the same method to the board with 25 cycles, get your cycles back with cycle max speed. Very different stories. Yep, my bad. That's words. So edit. So I have to, in the apply click, I need to go pull from bag if applicable. Yes. Boolean. This should be true, but yeah. Cool. So this is going to target a random cell from the bag, and then it's going to apply the click only if it's available from the bag. So let's see if this looks like what we want. Run it. 25. Speed, go for it. So this top left little red square is actually what the bag is. These little squares in this first one represent clicks. And you can see how no click is, it's only drawing from the clicks that are red, which means available to click. All right, it's gonna only pull from these last ones and invert. The solution, when it no longer has any in the bag, even though the script can keep running, like we can set it right now and run or whatever, we can click target cell at random, but there's like nothing left for it to pull from. Apply click, it can't because there's no more in the bag. If you click every cell in the game, in the board, your result is invert. And you can see here, it followed all the rules that you would follow if you followed exactly what those rules were. So cool. That's the next level of complexity. Let's consider one more thing. Let's add to our random click, and we say add node. So now we want something to happen. So we're going to start our first conditional, and this is going to be count. That's not how you spell count. Count the lights. We're going to say add a node if, and the word if should just pull up the right one, but it's actually if output. So if the output of this previous node is a certain thing, then we're going to do something else. We're going to add a node. I'm going to say feedback. Boom. Okay, so now we scroll down and say count the lights. What does this one say? Counts the number of lights in the grid. Cool. No need to do anything fancy there. If output. So if it counts the lights, we want to say, hey, is the number of lights at least 12? If so, no matter what, jump one more node down and play that next node. That's why it's -1. If we said, well, we'll go get over that in a second. So then in the last node is feedback. We only want this sound to play. I'll pick a random sound from the bank there. We only want this to play if the if statement is true. So I indented it. And you can even see in the hierarchy, indented nodes have, I can even add a node, empty, because my UI is so good. So you can clearly see the feedback node here is indented. It's only going to play the indented logic if the previous one forces it to go into there, and that's only if it's true. So let's save. X blank field, run it. Run it 25 times again, and go for it. So you shouldn't hear anything right now, and I'll turn up the sound. Oop, no. And now you hear it. Oh, so the sound stopped playing, but then it started playing again. That means, oh, less than 12, less than 12, less than 12, less than 12, more than 12, more than 12. I wish my speed were working. I don't know why I broke it or how I broke it. But yeah. And now it's still playing the sound, but it's not making you more clicks because we ran out of clicks in the bag, but the script kept cycling about 2 more times. And look, there were certain times in this string, right, where there was less than 12 lights lit on the board, and you could hear it when there was more than 12, it made a sound, and when it's less than 12, it stopped playing the sound. So that's really cool that you can start changing the feedback of what's happening based on things that you pay attention to or conditions you want to program in yourself. But here's the second cool thing. Let me see. The history is all here. I can go into the Overwatch tool, and the Overwatch uses the same scripts, but I think it doesn't allow you to apply clicks. So when you play, like let's say I play from here, it does let you apply clicks, and that's not what we wanted. No big deal. We're at turn 93. Let's go into the method shaker, edit, random click. And now we want to never apply the click. So let's do this and just delete it. Save. We were on turn 25, so let's go all the way back to turn 25. There we go. See? Everything's stored, no problem, in Overwatch. So I'm going to run this new one that has no more clicks. So it still may target the cell, and it still may count the lights, but apply click? What? Make sure that you're supposed to be deleted, apply. Why are you still here? Well, okay, so it's gonna count the lights. You know what, might as well just not even target a cell at random anymore. Delete. It's going to count the lights. We're going to if output. And we're going to feedback. Feedback's going to be sound number 2. And feedback's going to be indented. If output is going to skip to that one. Only if it's 12 or at least 12 lights in the grid. Save. It's freaking out. Let's see if it worked. Let's see if this target cell at random there. Save, exit. Deleting things. Okay, well, we'll just make a new one. I should have just done that. Make a new method. This one's going to be called sound off 412. And write if there is more than 12 lights. Save method, add a node. We're going to say solve. We're going to add a node, we're going to say count. We're going to add a node and say if output. We're going to add a node and say feedback. Not hard once you get used to it, but I don't think anyone on the planet should get used to this. That's okay. I'm on this planet. Minimum 12. It's going to skip down -1. I'm gonna count the lights, and that's it. Save. So we came to this situation here. So like I got my Overwatch sound off for 12, and now when I play, if there's ever 12 happening as I'm playing, you'll hear it. It's a light sound effect, but you can still hear it on top of the sound effects that are being played. So sometimes you might want to ask yourself, like, well, how many times were there 12 getting up to this point? And that's why I make this scan history feature. Cool. So it goes through the whole history of what you played and applies this Overwatch to it. So no matter what your Overwatch is, if you wanted it, you can program it for whatever. But this is a really quick way to look back over the history of what you did and be like, did I actually XYZ? Like, it's whatever you want. So in this case, you can just hear it, how many times there were more or less than 12. Cool. Now I know at the end there was a solid over 12. And that's what you can do with Overwatch and scan history feature in Overwatch. You just play and it's there to back you up or, you know, mess you up in that first example I did. So that's the Overwatch system, the scan history system, the if functionality, the node functionality, all working together. But what if we want to do something a little different, right? I think, well, we go to the thingy and we're like, okay, let's build a new one. Make a new method. So this one is going to manipulate the turns. So like we're going to call this rewind timer travel. My dad hates time travel. That's the note. Save method. Add a note. We don't really solve. It's like the easiest one. We don't really need one there. Save it. So now let's just pick a different condition. Let's say count the turns. And we want to count the turns from the start, the anchor, the method shift. That's crazy. We'll get to that in a second. So start. So if I ever go, well, it's just going to count them. Now I need an if output. So let's say I'm one of those kind of players that like to click really fast. So me being Richard, I'd be, well, I'm looking at another player. So I'm like, hey, I don't want you to develop that bad habit. So I'm going to make it to where every time you get 12 clicks in, 12 or greater clicks in, I want to do something, right? And I'm not just going to freaking play a sound, right? You need to learn your lesson. So it's going to count the turns. And if the output is ever beyond 12, we're going to reset. No, we need to rewind. Rewind turns. Rewind X number of turns in the grid. We're going to rewind 11. It's cool. You can use the output, right? You can take the output of the another node and be like, I want you to rewind that many times, but that's nonsense. So 11 is fine. But we only want this to happen if it's there, so we do that. And we check the output, and it's going to be -1, cool. And we save it. So now, this is kind of the let's reset it. We're at turn 0. We activate Overwatch, run it, scroll down one, and rewind timer travel. And I might as well save the whole game like that. Overwatch, run it. So now I'm just gonna, that's not what that was. Oh, every time you scroll, it resets my terrible UI. Yeah, okay. So now you can just play like normal. And you're like, okay, well. Crossroads. Waffle. Invert. Ah! Now, I should have put a sound effect in there so it wouldn't surprise myself, but you see how instant that was? We're back at turn 1. Probably should have done 12 turns, but so that's pretty cool. Like, we're back to turn 1, and I did not, let's just say, like, that's helping me stay focused to where I came from. So now I can be like, okay, this. Oh, Reflegia. Oh, went back 12 turns. You're like, oh, so it's always going to be there even if I forget about it. All right, so let's modify it. Rewind time travel. Let's not go back 11 turns because that's stupid. Let's just go back 6, right? Half. Like that. Let's add a sound effect. Nope, that's not how you add sound effects. I killed it. Good old UI. Six. Save. Add a node. Feedback. And whenever it plays an indented node, it's going to keep playing indented nodes until it gets to a non-indented node. So this is how you bracket off a whole series of things, right? Pick sound effect. We're going to pick sound effect 3. I don't know how far those go. So 1, 2, and 3 I know work. Yeah, it's only going to play the sound if it does me dirty like that, right? And now it's only going to go back half the numbered turns. Cool. Overwatch. Scroll down first. Run it. Time travel. Now you just play. Inside of here is fangs. Oh, a funny little creeper dude. That's cool looking. Like a Space Invader. Oh, I can see the time it jumped back. If I really wanted to go forward, I could go back manually because it's still all within the game's rules, like this. Like nothing is lost. It was probably on something like this. Yeah, and then you can keep playing. You're like, oh, it just reset me again, huh? But I had 12 clicks before, but I started with, yeah, now I have 6. So like, that's not good. And you're like, okay, cool. Go here, we edit it. Edit. So now we wanted to rewind turns. Well, deleting nodes gets a little tricky, but essentially we want to rewind turns and set an anchor. So we're gonna add a turn and we're gonna anchor. ANCHOR. So set an anchor to current turn. Hopefully this works. So we're gonna rewind 0 turns back. Let's see if that breaks everything. We're gonna set the anchor to the current turn. Indent. And then we're going to add rewind to anchor. Right? And we're going to count the turns from anchor. Save. So now it's going to let you do 12 turns up, cut you back 6. Wait, it needs to set the anchor after it jumps back. Actually, we don't even need to go back to the anchor. We just need to go back 6 turns. And then we need to rewind. We just need to play it in the set the current anchor. And it's only going to trigger once we are 12 from the anchor, right? Because it's only counting turns from the anchor. Cool, that makes sense. So we don't even need this final node here that says rewind to anchor, which we will delete and hope the delete system works. So let's get Overwatch. Scroll first, run it. Cool. So now 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Went back. Hopefully set the anchor. I should be able to go 12 forward and it'll kick me 6 back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. So now like I'm making progress in my exploration, but it's setting me back so I don't go too crazy. So now here I can get back to the solving. But in 12? Nope. Couldn't get there in 12 clicks. You're like, well, maybe I need to do a different path. And that's kind of interesting how the rules are forcing me to think about things differently or in a new way. So let's run with that. Let's make it more annoying. It's going to keep erasing my progress. Unless, let's put one more condition in here. Edit, rewind, edit, rewind time travel. So we want it to, the condition not just to be if output for counting the turns, but we want like 2 conditions, right? So how do we do that? Well, first, what is our new condition? Let's add an empty because it helps us organize. Like that. And then now let's add we only want to rewind turns if it's not on a recognizable puzzle. So let's add a node and say current shape. Let's just type in shape. Find custom pattern. No. What is it? Scan for known pattern, right? So now it's going to scan for known pattern. And if it is a known pattern, only if it's not a known pattern, so let's say single index, multi-index, as in we can like specify very specific shapes to look for. Note index, so like I think I was going crazy with that feature, but let's see. Note index. I think I wanted you to put in an index for a note that you took in note mode, and then it's going to look at the light pattern associated with that note and then confirm like you've gotten back to the note. So that's insane. But we're going to check for all patterns. No matter what, if it's question, question, question or whatever, then it's a known pattern. So cool. So we're going to say done. Now, if that's false, we need an if statement. So we add a node, if output, like this, and we scroll down. So we want to know when that thing's false. So if it scans for a known pattern, what does it actually yield? Output array 2 values, shape index and child index. What? Let's just assume it has a Boolean and see what happens. True, false. So like if the things coming out of here is false, then we want to rewind the turn. So let's see if this works. So what's cool about this is how you make nested logic. I'm going to indent this, and I'm going to indent the scan for known pattern. So now in the script as it reads down, it's never going to access this one because the one on top of it is not an if, right? So the only way it can access this one is if I go to this if, and I say, if this one's true, let's go down 1, 2, 3. Let's hope this is how it works. Go down 1, -1, -2, -3, -4, -5. We need to go down -5 and hop to that slot right there. So let's hope this works. And then once it's in this slot, it's going to evaluate and scan for known pattern. And if this known pattern is false, we're going to actually jump back up into this rewind turns bracket that we have over here. So like it's going to jump up 1, 2, 3, 4, 5. Okay, so +5. And then it'll play out like this. And then it'll go to the empty node, and then it'll just skip through the bottom because nothing else directly jumped into it, and that should be it. Now this could just crash utterly, but that's okay. Let's reset, get our Overwatch going. Scroll down first, edit, run it, rewind timer. It's got all this logic in it now. So, go for it. Okay, so clearly not a known pattern. We can go all the way forward from from where it jumped me back. There's no question. The system doesn't recognize any of these as a pattern, right? So it jumped me back. So let's keep going and see if we can get a pattern to prevent it from jumping us back at 12 moves. But it's jumping me back 6 every time, so it's kind of neat. Known pattern. I guess I'd have to land on it on the 12th, but you know, let's give it a good old 50-50 and let's just try to no. 1, 2, 3, 4. So how can I turn this into a known pattern in however many turns I have left? It's interesting how it kind of makes you remember what you just did, so that you can potentially just rerun it again. Because if you're clicking so fast that you don't remember what's happening. I think I can turn this into quotes. Ah, it's not quite quotes. Hey, so here I can easily... Oop. Well, it looked like it had a known pattern and it still kept kicking me forward. So let's do this. Well, it didn't work. I don't know if you can jump. Well, you have to be able to jump down because that's what's causing the sound effect in the first place, and then it's running that script and jumping back up. But yeah, like you can see how messy it gets with the jumping system. That was what it was supposed to illustrate. But you can always do this. Method shaker. Let's make a funny one, right? Like random clicks. Target cell random, count the lights. This is the one I messed up because I tried to delete stuff. Oh, man, screw you. Let's make one called scramble board. Random clicks for you. Save. Add no solve. We're gonna say save. Add node. Multiple clicks. Now let's just punch out a pattern, right? Punch out a pattern. Remove. I don't even know if this one works. Remove a whole thing in the grid. So we're going to I don't know my indexes that well. Multiple clicks. Apply multiple clicks. Punch and so we're gonna randomize. Let's just apply multiple clicks here. So pull from bag. We don't care about. Let's just click this. Let's just make a small box appear in the bottom right. And since I already know my solutions, I can just do this. Okay. So that's going to apply all those clicks in one turn. You go, cool. Save it. And it's if the puzzle, this is called scramble board, right? And it's going to apply a bunch of clicks, and we're going to add a node for feedback. And we're going to make this one number 1. So after it does it, it's going to be like, yo. Okay. And then we're going to go back to our method shaker and go to our rewind time traveler, and we're gonna say this is probably gonna break. Scan for known pattern. I feel like this is the problem.
I have returned from my bike ride.
Oh, what up, man?
I listened to like the first like 30 minutes of that of this book called what was it called?
I'm currently doing a recording. Hold on.
Oh, okay.
I actually got my scripting thing to work, so I'm running through some examples.
Good stuff.
If output, so this is supposed to be true. If output is true, so only if it's a known pattern or something. So instead of making it rewind turns, -1, I'm going to make it scramble. So I do this, that. I'm going to add method switch. It's going to go from this whole method that we just made and load up a whole different one. And I'm going to do it indented. And I'm going to say, use to transfer a completely different method from my methods collection. Users will be able to manually reset their heat maps. Should be able to. So like method index, total cycles, reset, bags, and maps. I have to put the index in there, so I think it's the 5th one. Save. What is it? So it's 1, 2, 3, 4, 5, 6. It's either 5 or 6, so let's bank on 6. Let's bank on 5. And if it's 6, we can adjust it. If it's 5, it might crash. Run it. So in 12 turns, it should apply a bunch of clicks, I think. Or make a small box appear in the corner, so we'll get rid of that. See if it appears. What happened? So it rewound and played, let's see, Overwatch. Rewind time travel. So which sound did it play? It played that one, huh? If output rewind turns. So we don't want it to rewind turns.
Mic off.
Okay. I'll wrap it up here.